In question 2 of this series, we're asked to solve the equation square root of x squared plus 1 times y prime plus 3x times y to the power of 2 is equal to 0, subject to the conditions y at 1 and x at 1. The first thing that I'll do to tackle this problem is switch y prime into dy over dx. So let's go ahead and do that. We have the square root of x squared plus 1, that hasn't changed, but this has become dy over dx. Plus 3xy to the power of 2 is equal to 0. What I want to accomplish here is to create two separate terms that are dedicated to one variable only. So I want one term that's dedicated exclusively to x and another that's dedicated exclusively to y. And this is usually the difficult part with these questions, that is to manipulate these equations in such a way where you have those conditions. So here's what I'll do. And before I show you, you can pause the video now and try it yourself. See if you can create separate terms that are exclusively in terms of one variable. It's harder than it sounds. So here we go. We'll take this term over, and that makes it negative 3xy to the power of 2, and the left side stays exactly the way it is. Next, what I'll do is multiply both sides by dx. So if I multiply the left side by dx, this will cancel out with this dx, and on the right side we have dx. What I want to do next is divide both sides on the right side by negative 3x. What I really want to do here is make the right side exclusively in terms of y. So I'll divide the right side by negative 3x. This will cancel out with this term, and on the left side, giving us the following, and I'll show you a cleaned up version of this equation, and there it is. Now since I want this term to be exclusively in terms of y and this one in terms of x, I need to bring this dx to this side and this dy to this side, and I can do that by dividing both sides by dx and dy. So if I divide this side by dx, I need to do the same thing here, and if I divide this side by dy, this dy and this dy will cancel out, and we'll have dy on the right side. Finally, what I want to do is make this dx and this dy in the numerator position, and I can do that by reciprocating both of these fractions. We are now ready to integrate. We have accomplished what we want to accomplish, and now we can integrate with respect to x on the left side and y on the right side. To integrate the left side, it's a little more involved than the right side. We have to do a substitution, and namely I'll set this part equal to u, where I have u is equal to x squared plus 1. Now I'll derive with respect to x, so this side becomes, using the power rule for this term, we have 2x dx, on the left side we have du. I'll solve for dx so I can replace it with what this expression is. We have du over 2x is equal to dx. So now I'll replace this dx with du over 2x. Notice what just happened there. We can now cancel out this x with this x and also pull out this negative 3, where I have negative 3 outside the integral of du over the square root of u. And of course, you should have a 2 right here. So before we integrate 1 over the square root of u, I'll pull out this 2 so that we have negative 3 over 2, the integral of 1 du over the square root of u. To find the integral of 1 over the square root of u isn't hard. You do need to use your exponent laws, where 1 over the square root of u is the same thing as u to the power of negative half. We add 1 to the exponent, we take its sum and divide this expression by that sum, which is half. This ends up giving us 2 times u to the power of half. And this is the same thing as 2 times what we set u as, which was x squared plus 1. And this half exponent means that it's a radical. So we have x squared plus 1. Therefore, the left side has become negative 3 over 2 times 2, and I'll write this out, but it will cancel out, times the square root of x squared plus 1. This 2 and this 2 will cancel out, leaving us with, on the left side, negative 3 times the square root of x squared plus 1. Now we move on to the right side. We have to integrate 1 over y squared. That's not hard. 1 over y squared is the same thing as y to the power of negative 2. We integrate this easily by adding 1 and then taking the sum and dividing it by that sum. Gives us negative 1. So we have negative 1 over y is the integral of the right side. Let me write that down underneath. Negative 1 over y plus c. We'll take this term over, and now we can evaluate this equation at y is equal to 1 and at x is equal to 1. Setting this equal to 1 and this equal to 1 gives us 1 plus 1 is 2. Negative 3 times the square root of 2 plus 1 is equal to c. And this is approximately equal to 3.24, which you can confirm with your calculator. So our solution when y is equal to 1 and x is equal to 1 is 3.24. And officially you should place this expression right here and you'll be done. So your final answer is 3 or negative 3 times the square root of x squared plus 1 over y is equal to 3.24. And there you have it. That is how to solve differential equations when given conditions.